Hi everyone, this is Mr. Kong on my chemistry revision series, and today this topic is on separation techniques. Now, this is an overview of what we're covering today. We will look at why separation techniques, and we'll look at the criteria for a pure substance to be considered pure. We will also look at three main separation techniques: simple distillation, fractional distillation, and chromatography. Now, why separation techniques is because many of the things that are around us are not pure and they are always mixed with other kinds of substances. And we definitely want to learn about separation techniques because we want to ensure that the things that we use can be pure. And we want to remove the contaminants as best as we can to maintain purity of substances. And the criteria for things to be pure, to be considered pure, will be in terms of the melting point as well as the boiling point. And they have to be fixed. Fixed means one precise constant value. For example, for water, it is 0 degrees Celsius for the melting point, and the boiling point will be 100 degrees Celsius. And similarly for ethanol, the melting point and boiling point are fixed at that particular conditions. Now, impurities have a certain effect on substances, and especially in terms of the melting point and the boiling point. Generally, impurities lower the melting point of a substance and raise the boiling point of the same substance. Now, simple distillation is the first separation technique that we're going to look at, and it is very good for removing the solvents from a solution. Now, this setup is something that is familiar to you. It is good to remove the water from a sample of salt water, for example, the seawater that we always use when we are, as an analogy, when we are stranded on an island. Now, the thing that you need to take note of will be the condenser, the position of the water in and the water out, as well as the purpose of adding boiling chips into this setup to ensure smooth boiling. Now, where does boiling and condensation take place in simple distillation? Pause this video and think about this. I hope you have had time to think about where the boiling and condensation take place in the setup, and they are none other than the locations as stated in the diagram here. I hope that you got them right. Now, for the next separation technique that we're going to look at, it will be fractional distillation, which is quite similar to simple distillation. Now, this is very good for separating liquids that mix very, very well together. And the separation now is based on the boiling points, where the lowest boiling point will be separated first. This is the diagram, the setup. And the main thing is that there is a fractionating column as compared to simple distillation. And the purpose of this column is to ensure a greater surface area for separation to take place. Now, which liquid A, B, or C will be collected as the distillate first? I hope that you manage to think immediately that the one with the lowest boiling point, which is liquid A, will be collected first. Now we move on to the third and last separation techniques for today, chromatography. Chromatography is based on the solubility of the pigment in the solvent. And generally, the more soluble it is, the further it travels up the chromatography paper. And if it is insoluble, it means that it will not even leave the start line. It will stay on the start line. And we can use chromatography to look at various stuff. For example, we can look at whether a substance is pure or a mixture. A pure substance will leave only one spot on the chromatogram, whereas a mixture will have two or more spots seen. In this case, you can tell that blue, red, yellow, and green ink are pure substances, whereas the black ink with 3 spots is a mixture. Another concept that is related to chromatography is the RF value. And this RF value is a measure of how far your pigment has traveled along the chromatogram, and it is also a measure of how soluble it is in that particular solvent. The way to measure is shown in the formula on this diagram here, and you have to usually measure the distance from the baseline to the center of the spot. And this is a recap of today's summary video, and I hope that you have enjoyed this particular video here. Thank you. See you again.